So we actually have a couple of values over here that we're going to try to plot in that and so let's actually try to sketch it. So that's a sketch of all the values of ionization energy across the period. So there's a very distinct thing about this is that suddenly at group 3 there's a drop, and suddenly at group 6 there's a drop as well. So you have to be able to explain why are there these two drops over here in the ionization energy. Let's attempt to explain this. So the first observation is that ionization energy of aluminium is less than that of magnesium. So write down the electronic configuration of each of these atoms and their corresponding ions and pause the video, and then you can compare your answers. So see the electronic configuration. So when you look at magnesium, so electron is being removed from the outermost shell, which is the free s from the free s orbital actually. So this is the electron that's going to be removed. So you end up with free s1. Now if you look at aluminium here, you're removing actually from the free p orbital. The free p orbital is further away compared to the free s orbital. They are from the same energy levels, yes, but free p is a bit further away than free s. Because it's further away, there's going to be less force of attraction because when the distance between the nucleus increases, therefore the force of attraction is going to be less. Ionization energy is definitely going to be less. Okay, so for magnesium, you're removing electron from the stable electronic configuration state over here. So this is a completely filled orbital, so it's stable. But aluminium here, you're removing electron from a p subshell, from a p orbital, which is further away than the free s orbital. So it's further away from the nucleus than the free s. Therefore, less energy is required to remove the electron. So ionization energy. So it's further away. Ionization energy is going to be less. So this is why you have that drop. So electron is removed from the free s and free p orbital respectively. Free p is further away, less energy is required to ionize. So if you're trying to explain that, so at group 3, electron filled in free p is further away than that in free s, which is for the group 2. And therefore less energy is required to ionize group 3 elements. Let's see for sulfur and phosphorus. So again, complete the electronic configuration and then you can check. So for this one, you can easily see what is happening and why is the phosphorus more than the sulfur, or why is the sulfur less. So if you look at the electronic configuration of phosphorus, you can see there is a half-filled orbital. So this is half-filled. The subshell is half-filled, which means that it has extra stability. So you're removing one electron from a very stable configuration. So very stable electronic configuration, so it's going to be more difficult. But when you look at sulfur here, it's free p4, and if you look at this orbital over here, you can see there's going to be mutual repulsion because electrons are negatively charged and they repel each other. So mutual repulsion. Because of mutual repulsion, this electron, one of these electrons, is going to be very easy to remove. So remove it, it's going to be willing to go away. So easily removed due to mutual repulsion. So in the explanation, it's easier to remove an electron from sulfur due to mutual repulsion of two electrons occupying the same orbital. So same orbital here, mutual repulsion. Electronic structure of sulfur is slightly less stable than that of phosphorus. So because of that mutual repulsion, hence it's more difficult to remove electron from phosphorus. So here we want to explain why there is a drop, not why this or this is higher. So when you're explaining, you have to explain why the group 3 and the group 6 are lower. Do not explain why group 2 and group 5 are higher, because the trend is actually going up. Ionization is actually increasing. But these two situations are the exception. So this is what you have to explain. So explaining for group 3, it's because of the P3P, which is further away. And if you want to explain for the group 6 here, so it's because of mutual repulsion of electrons occupying the same orbital. So you know that these two will repel each other, therefore this electron over here is going to be very easy to remove, right? So this is what you will need to explain in many questions. And you can see a similar trend in ionization energy observed in period 1. So in all the periods, you're going to see this trend. So it goes up and then goes down. That's group 3. Goes up again and then goes down at group 6 and then goes up again. The group 3, you have to know that it's because of electrons being filled in an outermost in a subshell that's further away, so it makes it easier to remove. And for the group 6, it's because the electrons will have mutual repulsion because there's two electrons in the same orbital. Okay, so with this we end today's lesson. Make your notes properly, and then tomorrow we're going to move on to variation of ionization energy down a group. Okay, so that's for tomorrow.